Hello, everyone, and welcome to our webinar, Fast AI on JSON, using OpenAI to build a real-time recommendation engine. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a SingleStore webinar, heads up that we present weekly technical workshops demoing data and AI use cases and new technologies. In fact, next week on Wednesday, we'll be presenting ChatGPT for product-led growth. And Akmal, do you want to pull up your screens and we can share this? We can show this slide. So, like I mentioned, we'll be doing ChatGPT for PLG. Talk to your Salesforce or segment data. We'll have a hands-on demo during which you'll be able to learn how to build a conversational application with LangChain and a vector database, handling multi-model data, all while keeping your data secure and private. So if that sounds interesting, feel free to hit this bit.ly link. I'll put that in the chat in a minute. You can also take a photo or a screenshot of that QR code and register right now, and hopefully we will see you next week during that. Also, I should mention, you can register even if you can't make that date and time, and if you do, we will automatically email you the video recording and the related GitHub link after the session. So back to today's topic. FYI, we are going to have a technical audience Q&A at the end of today's session. Akmal will be able to answer your questions after his demo and his screen share. We'll also have some of our technical and product experts coming in, but again, that won't be until after today's session. Also, we would love for you to try out today's technology. In fact, anyone who tries it out today will be entered for a chance to win brand new branded AirPods Pro. Simply click this link that you see on your screen right now, that bit.ly Fast AI JSON raffle. You can also hit that QR code, take a screen capture or a photo. All you'll need to do is log into the screen, log into SingleStore after you arrive at that link. You can log in to create a free trial if you're a new user, or you can log into an existing account if you're already a customer or if you're an ongoing free trial. We're going to check the folks who have logged into that link. I'll monitor that and we'll announce a winner at the end of today's session. So let me introduce our speaker for today. Akmal is a senior technical evangelist at SingleStore. He has strong expertise in big data, machine learning, and AI. He's a prolific author and a regular speaker at our weekly webinars on data and AI. Welcome, everyone. Akmal, you now have the floor.
Great. Thank you very much, Matt. And thank you to everyone for joining. So I think we may have a worldwide audience. So good morning, good afternoon, good evening to you, wherever you are. Thank you very much. We know your time is precious, so hopefully it's going to be very useful for you today. And let me just do one more thing before we move on. So this link here for this, sometimes we are asked to actually show where does this actually go, and bear with me. So I'll share the entire screen, which is makes life a little easier. And I'll open this in a different browser, Safari. And again, Matt, please keep me straight. So if I'm saying something and you can't see it, please let me know. So there we go. There's where the bit.ly link will take you. So, there we are. Privacy settings. So this is useful, and I'll just accept all for the moment, but make your choice there. And so once you do this, I mean, literally, it's a very, very fast process, 2 minutes maximum. Either use Google or Microsoft there, or you can choose your credentials there another way. Your company email address is preferred, and $600 of credits there. Very useful. So all I'll say here, you might think, well, $600 is not very much. Actually, I've been with the company over 2 years now, And before I joined, I signed up for this account. In those days, it was just $500 of credits. But even that same account, I have it today and it still has credits. So I use it regularly for building demos and small-scale trials and things. So there we go. And as Matt said, if you sign up, you'll be in for the AirPods Pro. He can say it better than I can. All right, let's kill that. There we go. And let's get back to the slideshow. Just make sure I'm sharing the desktop with you. There we go. And so that's today's raffle. Again, I'll leave that there for just a moment. So if you wish, you can scan the QR code. But the link there, Matt will post it into the Q&A in the chat. Okay, there we go. So what's the focus for today then? So we are going to do a little bit of focus around SingleStore Kai. So if you attended the previous webinar that Vijay and I did not so long ago, I think it was just last week, and Jason, of course, who's the lead engineer on this technology, has been delivering webinars as well as awesome YouTube videos as well. So we're going to focus a little bit on that today, but we're going to look specifically at one area of this, which is this CDC, Change Data Capture tool from SingleStore. Currently, it's in preview. There's several elements to it. And so what I'm going to show you today is something you can actually try for yourselves today. You don't need to sign up. You don't need anything particularly enabled for that. And that will give you some, if you want to get started and just, dip your toe in the water kind of thing, this is a great way to test it out. And all of the assets for today in terms of the notebooks, the SQL code, and the Streamlit application, which I've got towards the end, it's all on a GitHub repo. As I was discussing with Matt just a short time ago, I do plan to write up an article. So if you follow me on Medium or dev.to, you know that I do these quick tips, which essentially it's, I think in the US, you refer to it as soup to nuts. So I talk through and describe the content, how you can get started, what you need to install, settings, parameters, everything. So at the beginning, you assume no knowledge. By the end of it, hopefully you've replicated everything that I've been able to do as well. So we'll try and get that article out very soon. We're also going to look at OpenAI embeddings, particularly with JSON data. Now, Jason, my colleague, not related to Jason, the data type, but he actually did a webinar very recently as well. He focused on one aspect of this, and we're going to look at another part of this story. And at the end, we've got a very simple kind of recommendation engine that just using Streamlit, I've been able to build, and we'll sort of demo that as well for you. Okay, just a few words about SingleStore. So what is SingleStore? It is a database management system, first and foremost, okay? So to avoid any doubt or confusion, it is a DBMS. And it comes with a variety of features and capabilities, which make it very, very unique in this market space where, you've got a choice of hundreds of database management products. Fast ingest plus CDC, okay? So we'll be looking at the CDC aspects, particularly as it relates to SingleStore Kai today. But pipelines is a feature that it's had for some time. And again, I've written about this in the past, how to use Kafka, for example, to stream data into SingleStore using pipelines. And that's something that we're thinking about demoing again in the very near future as well. And it integrates with a whole bunch of other technologies too. Apache Spark, for example, for transforms and machine learning as well. Bulk load of data and so on. It runs on the three major cloud platforms that we have in the Western world: AWS, Google, and Microsoft. Also runs on-prem, and there is a Docker container as well. So if you go to github.com, SingleStore, I think it's -labs, you'll find the details of the Docker container. And if you sign up, you can get a license to actually install a 4-node version of this free of charge. Okay, and that you can do that on your own hardware or in the cloud if you want to. That's entirely up to you. Okay. The other nice aspect of the product is its ability to deal with lots of different types of data. So naturally, it is a relational database management system. But in the past, and not long after I joined, I started looking at some of its multi-model capabilities. So geospatial, for example, full text search based on the Lucene engine. We can do key value. JSON support has been in the product actually for quite some time. And there's been quite a number of optimizations around that. And earlier this year, I mean, Matt will remember this, we did a webinar on this and talked about some of the nice capabilities and the speed ups that we see. I mean, immense performance improvements in terms of the working with JSON within SingleStore, not to say all the other things that have come about as a result of the of Kai. Time series as well. And last but not least, vectors. So just today I was reading yet another vendor has added vector support. Well, congratulations, okay? But yeah, the product has had this capability since 2017, all right? And I know it's a kind of a hot topic these days because OpenAI, you know, LLMs, all of this kind of thing, ChatGPT, Bard, and so on. And people are really interested in looking at how to, you know, leverage this capability. But keep in mind that within SingleStore, this is tried and trusted technology that's been around for quite a long time. It was actually requested by one of our financial customers, I believe, originally. And there are a range of functions around this, of which we'll get a chance to look at one particular one today, which is .product, okay? So we'll see a little bit more about that shortly. Okay, applications, real-time decisions, AI apps, dynamic experiences, and then analytics is really where the strong focus and usage is. And obviously, we're seeing a significant interest as well with the wide range of integrations that we have. So having this vector support has been, you know, awesome for us. All sorts of other great things have been released. So, for example, if you attended the webinar yesterday, you would have seen my boss Madhuka talking about the plugin, the ability to do MarTech, and you know, you essentially query the database in English and have the opportunity to get your answers back in meaningful sentences. I mean, that's really, really, you know, a great differentiator. I mean, SQL is great. Not putting that down, and it's not going away anytime soon. But I think it's great to have all these alternative mechanisms as well when we are working with database technology. So multi-model capabilities, the two in particular that we are going to focus on today is the JSON here and vector functions to some degree. I mean, there's a lot of these vector functions, like I said, but you know, we won't have the time or the opportunity to talk about everything today. But the thing is that within SingleStore, there is the chance to use these together. So as I said, Jason talked about this in his webinar last week. Vijay and I touched upon it a little bit in the last webinar we did, but today we go into a little bit more detail. And it's important. Why? Because it's so widely used in terms of financial data. There you can see supply chain, social media, customer analytics, IoT, log machine data, telco, and so on. Okay, so you know, lots and lots of diverse use cases around the world. Many verticals, many industries are using this type of data, and it's important. Okay, and therefore we need to look at this and be able to support it well for these customers that come to us who have these requirements. And so the key thing, and by the way, in case you're wondering what Kai stands for, and Matt will set me straight, but I believe it's Kaizen. That's what it's short for, SingleStore Kai. So with MongoDB compatibility. So this gives you, if you are a Mongo user, the ability to work with your favorite tools and be able to leverage all the awesome performance that SingleStore provides, particularly if you're working in analytics. And so you can really get the benefit. Performance-wise, this was something that was tested a little bit earlier this year. And sometimes people think that the larger the column, the better the performance. Actually, lower is better in this case. So you can see, if I just draw your attention to the first query here, and by the way, this is all published, okay? So there is a blog article that discusses all this in detail. And if you want to, you can replicate this as well. So if we take a look at this, for example, you can see that the green here, that is MongoDB Atlas, and this is SingleStore's performance. So, you know, almost 900x performance improvement in this particular case. In the last webinar that I did with VJ, I took the opportunity to actually run an IoT benchmark. Now, I didn't have the patience or the resources to see this through to the volume of documents that would really test it and scale and put a little bit of stress on the two systems. But even at this small scale, here is kind of 10% of the data. And by the way, again, this benchmark code is on GitHub if you want to try and replicate it. So this is using Atlas M80 NVMe, and this is using SingleStore S2. Okay, so this is using Kai on our environment, but using the S2 configuration. And the reason for that is that they are kind of comparable in terms of memory, CPU, and so on. And running it in the same kind of environment as well, same region of AWS, and trying to keep it a level playing field so that the comparison is fair. So these are the results of my tests. And Mongo has very graciously sent me a bill of $27 to pay for the services that I used for them for running this. So that's something that I have to reclaim through expenses, I think. But anyway, even at this small scale, you can see here the performance difference starting to make itself felt. So in most of these, you can see SingleStore is, not to be disparaging here, but kind of flatlining here, which just shows that its performance is constant, its throughput is awesome, and it's really doing well in terms of this performance benchmark. Okay, so how to utilize this? Maybe you have invested a significant amount of time, effort, and money in MongoDB. So one of the characteristics or one of the mechanisms that you can use is that in this particular scenario, you don't have to give up MongoDB. Okay, there is a question of, can you augment it? And SingleStore can act in this capacity as something that can augment your existing Mongo investment and your existing technology. So Mongo might be great for transactional data, but for the analytics, SingleStore can handle that. And so there's a variety of ways that you could get the data from your Mongo environment into SingleStoreDB, of which I've discussed a number of these techniques in the past, but you can probably guess a few others that would be easy to use, things like Mongo export, for example, and import. You could just export as a JSON document, for example. There are technologies such as Hivo data, for example, which I've demoed as well. I think it was earlier this year. There was a blog post about that. And so another possibility is to use this mechanism here, this CDC replicate and pipelines sort of capability down at the bottom here. And that's what we're going to focus on particularly today. The other possibility is that, okay, you may be in that situation where perhaps your Mongo investment is not so significant and you are looking for something else to address the pain points that you may be experiencing with the technology, and therefore a complete replacement of Mongo might be possible and something that you might want to consider. And so that's doable as well, okay? And so currently, the Kai is available on a variety of AWS regions, and Azure is on the way. It's coming very, very soon. Okay, so enough said. So let's drill down to a couple of demos then, okay? So we're going to look at two examples. So again, if you attended the previous webinar that I did with VJ, we looked at this retail sales example, and I was a little bit critical in terms of how the data was being loaded from MongoDB into SingleStore. Essentially, we're just using a loop. Not a very useful way. I mean, it works, but for the scale of data, it's fine. I mean, it's not a huge amount of data, and that can be a very sort of, one way that you could do it. But today we'll look at how to use CDC. And then we'll look at this book recommendations where we'll actually do some embeddings as well. So we'll get some JSON data across from MongoDB into SingleStore using CDC, and then create some OpenAI embeddings for that data, and then ask some queries of it. And then finally, we'll build a small Streamlit application just so that I can type phrases in English for recommendations and get back some recommendations from the system based upon the embeddings that we've used. Okay, so for the retail sales, essentially, this is a great example of perhaps the augmentation scenario, in the sense that if you think about it, if you have an online store, and you can probably think of one of the largest ones in the world that I use a lot, there is a variety of requirements there. Some of these requirements are analytical, okay? Some of them are much more sort of transactional based. So things like giving ratings to products, or just adding things to your basket and then checking out. And then there is, more advanced things that you might want to do as well. But here, you might be happy with MongoDB to handle the transactional side of things, but SingleStore could help you and assist you augment Mongo to do the analytics. So the kind of scenario that we have is something like this. So essentially, we've got these two environments, and what we're going to do is we are going to copy the data from Atlas to SingleStoreDB, and I'll show you the code that's done that. And then what we'll do is we'll run a series of queries across both systems. Essentially, we are going to target both our Mongo environment and the SingleStore environment. Now, this is a slightly unfair comparison, okay, just to be upfront. And I say that because I've got a bit of pedigree in the benchmark space. I mean, I spent 6 years doing that as a postgrad and a researcher a long time ago. But one of the things that you try to do in benchmarking is level playing field, and to be fair, and try to ensure that the scenario is reproducible, the tests are reproducible. I mean, that is very important in academic circles as well. So we are using the shared environment here for Mongo. So please don't take the results to heart too much. I would suggest you run your own tests in your own time, but the key thing here is to demonstrate the ability of the CDC and show you how we've done that already. And therefore, the notebook itself essentially is just a few lines of code that have been removed. The rest of it works exactly as it did the last time I demoed this with VJ. Okay, so let's take a look at that. All right, so let me switch to a different tab here. Okay, and I'll blow this up here just to make it a little bit bigger. So before we do this, and before I run this, let me show you what I've actually done. Okay, so let me just make this a little bit bigger. Hopefully you can see that. And so what I've done is I've created a database. Okay, it's called New Transactions. And by the way, the data set for this, again, it's part of the GitHub repo if you want to reproduce it. And this is where we have set up this CDC, okay? So essentially, we've created this thing here. It's called a link, okay? And as part of that, I've specified some information here. So there are the MongoDB hosts, okay? So this is now connecting to this shared environment, and that's the primary there, and the two secondaries are slightly just off the screen there. And then we've got the actual database and collections that I'm interested in, specified on the next line. I've got my credentials here further down, okay? So I'm actually logging in as someone that has admin privileges in terms of read-write. And so once I've done this, essentially, all I'm just giving the system is this command here to say, well, take this, create the tables for me, connect to this environment, okay? It creates a pipeline, and we're using this Avro format as part of this, okay? And so if we take a look at this, okay, let me just move this up a little bit here, give myself a bit more space so we can take a look. So within this environment, let me show these pipelines. Okay, I have to just move things slightly out the way there. Okay. Okay, so currently there is, let me switch to the right database. So we are looking at the transactions one. There we go. Sorry about that. I forgot that I'd switched to the other database as part of that. There we go. So we can show the pipelines here, okay? So here we can see that from the Mongo environment, okay, I've got a collection on that side called items, another one called transactions, another one for customers. The status of all three of these is that the pipeline is running. Okay, so I've started that already. And what I have is that it's created 3 tables for me. And I can look at the definitions of these, so I can describe them here. And so again, let me just try and see if I can get this. Okay, so one of these tables is of type text for this one. Okay, this is customers. And then you can see this JSON type here. Okay, we'll take a look at this in just a moment. And similarly for items and transactions. And I can do this and take a look at a row, if you like. And you can see the kind of structure. Now, when I do this, it may not come across very well here, but you get the gist of it. Essentially, this is JSON, okay? So there is a unique identifier. You can see the $OID, which is used in MongoDB. And then I've got various fields as part of that. It's showing a part of that there already. And it's done that for the other 2 tables as well. So if I were to do a count here of how many of these there are in each table. So for the customers table, it's fairly small there. As you can see, it's 1,500 entries. For the items table, somewhat larger. It's nearly 150,000 entries there. And for the transactions, I've got, what's that? Nearly 75,000. Okay. So the point is that on the Mongo side, yeah, I'm sure they'll be pleased I'm showing their environment. But if I take a look at the collections that I have, you can see here that these are the collections that essentially the CDC tool is connecting to and copying across. Now, it's not just a copy process. That pipeline is still running. Okay, so when new data arrives on the Mongo side, it gets replicated to the SingleStore side. Okay, that's what's happening as long as that pipeline is running. Okay, and the technology is robust enough that if we were to shut this down later, if we were to restart it, it would connect and be able to find new records, the differences, if you like, and be able to move them across to the SingleStore environment. So that's essentially what's happening there. Okay, and I've done the same thing for the other example that we're going to use, which is essentially a bookstore. So with a bookstore, I'm very small in terms of the number of entries that I have. So you can see the structure very similar. I create this link. I'm giving it details of the environment. Okay, the primary there, and you can see just off the screen there, there's a secondary and another one as well. And again, my credentials there. What is it that I'm interested in? Well, I'm interested in this particular database here called Bookstore, and then the asterisk there is all the tables there. Well, there's only one collection over there, which will create one table on this side. And again, if we take a look just further down below here, I started those pipelines, and I can take a look. How many entries do I have? Oh, sorry. I need to switch the database. Okay, so I've got 2. There we are. Switch to the bookstore, and then we can do this. Yeah, there we go. So you can see very small number. Okay, that's fine. And we can take a look at the structure. So let's take a look at one row. And again, you can see the JSON structure there, very similar to the other one that we saw. So what's happening is that setting up these links, starting these pipelines, pointing it at a particular database and the set of collections, collections inside that we are interested in. And then that's being copied across to the SingleStore environment. And as those pipelines are running, if new data arrive on the Mongo side, they will be replicated across to the SingleStore side as well. So those have been running for a little while. I mean, literally within a few seconds, the data was replicated. But we're not dealing with very large quantities of data anyway. That's the key thing there. Okay, so in our example here, this is the notebook we used last time. Okay, so let's just run through this, and let me just clear this, clear the output here. Okay, so we can run this again. So this, previously what we did, we used a loop to be able to copy the collections across. In this example, we don't need to do that. Okay, so we just do a little bit of a setup here, a couple of libraries, and just some imports to get ready. Here, we're just connecting to our Mongo environment, as you can see, okay, as well as the items. Sometimes this hovering doesn't bring up the full name there. There we go. Let me try that one. No, it doesn't like it. Never mind. So let's just hit that. Okay, so that's fine. And then here is the SingleStore side, Kai. Okay, same thing. And this is the step that we don't need, just down here. Okay, we no longer need this because essentially using the CDC tool, we have done this process already and it's continuously running. So new transactions coming in on the Mongo side, all of that will get replicated across to SingleStore. So that is redundant now. No need to copy anything across. And we can check, okay, from there. We know this, we've seen this value already. Don't have to verify this, but there you can see it's roughly 150,000 rows there for this particular table. Okay, and we've seen this. And then the rest of it is just most of this code, as I mentioned the last time we showed this, it just deals with the generating these graphics, these charts, to show you the same operation being run against Mongo and the same operation being run against Kai. Okay, so again, you can see, you know, product quantity sold, average customer satisfaction, and so on. And typically, for most of these here, you'll see SingleStore does pretty well there. Although, as I said before, be a little bit wary. I mean, the difference here, if we take a look at the I mean, again, SingleStore is pretty flat there. Throughput's very good. Average customer satisfaction, and so on. I mean, you get the gist and you get the idea here. But for the analytics aspect of it, certainly, despite the the small innovations that we have, this realistically, you'd want something more substantial, larger data set, similar to the IoT example that I showed you a few moments ago. That would be a lot better. This query is taking a little bit longer to run. So you get a bit of a spike there in terms of SingleStore's performance, but overall you can see it does pretty well. And then here we go, number of transactions by location membership. So typical sum, min, max, average count type of operations that you would expect to see. And the overall performance here, you know, top 10 products and so on, okay? So there we go. So again, this is part of the GitHub repo, okay? So if you want to try this out for yourselves, you're very welcome to do so. Great. Let me just get back to the slides, okay? And let's just move on. Okay, so let's have a look at the book recommendations, okay? So here, it's very much, again, the architecture of using this CDC replicate. Okay, and again, I've shown that to you already, you know, using this pipelines capability, and we've already streamed the data across, and it's still running, okay? New data arrive, that can move it across. So the main thing here is that all of this aspect, in terms of the book data, doesn't have to come from an external source now, a CSV file or anything. It's already done. It's in Mongo. And here, the loader is really the CDC. What we're going to do is we are going to generate these embeddings. Oops, pardon me. Just try and get the right, this one. There we go. Okay, by calling OpenAI. And we're going to store these in that SingleStore. So currently, there's a couple of tables that don't exist, okay, which will be created when we run the notebook. You saw there was only one at the moment. There was the books table. Okay, and then what we'll do is we'll ask a query. So in the notebook, because it's great, I mean, it's interactive, but the thing is not very good for, you know, if you want to ask lots of different questions, you have to go back and change the text each time and then run it again. So there, hence the reason for using something like Streamlit, for example, just to build a visual front end. Because for the question itself, we need the embeddings for that as well in order to do the dot product operation to find the best matches for the recommendations that we are looking for. Okay, so let's move to that. And let's take a look here. Okay, so this is actually something that was built by one of my colleagues, Yaroslav. And so again, this is a slight change to the code that he has used, because he was loading in from an external file to read in the values, but we are just going to use the CDC capability already that you've seen. The table's already created, but we need to do a little bit more in terms of the embeddings and a bit of metadata. So again, just some installs and libraries there. Here we need to input our OpenAI key, and I think, okay, I'm going to have to just stop here a moment and get that, because I think I'm going to, there we go, it's on my desktop somewhere. There we go. Let me try and get this. Okay, just copy that. It should work, hopefully. Just at the bottom. There we go. Let's try this. And no, I don't want you to remember it. Some constants there, just pointing to the actual database, bookstore, and the collection books. And there's going to be a separate collection for the actual embeddings. I mean, there's a variety of ways you could do this, okay? There's no set way. It just depends upon your requirements. This particular example chose to do it this way. Okay, and then a lot of the rest of the code is just simply helper classes to assist with the process of handling the JSON and generating the embeddings and so on, and calling OpenAI. So I'll just run through these fairly quickly. Interestingly, this is the actual code for the storage of the embedding. So SingleStore uses, normally if you work in SQL, it'll be JSON array pack, JSON array unpack. But here you can see, so far, within the notebook itself, you have seen no SQL code. Okay, so this is all pure Python. So again, let's just run through this. There we go. Almost there. And finally, then what we need to do is, we know there is a books table. This is going to create another table just for some meta information. And then here, it's going to do the embeddings, okay? And then there's the search function. And again, there are a couple of extensions that SingleStore Kai supports beyond the MongoDB. So there's a Euclidean distance and dot product. Okay, so those are vector functions that we support anyway through the SQL. But Yaroslav here has used the dot product specifically, and this is an example of how we can utilize this, taking the embeddings that we have stored for the books with the actual query that we want to ask, and then performing the dot product upon that, and then returning a set of answers for us. Okay, so finally, after all of that, after working through all the helper functions and all the code in terms of generating embeddings, just 2 lines of code here. Load the source was that actually most of that code is gone because we don't need to do that. The CDC pipeline is taking care of that for us, but there was a meta table that we needed to create, and then just do the embeddings. Call OpenAI, take those books. There are descriptions of them, various other things, which you'll get to see in just a moment. We'll take a look at the JSON code there, and it's just running that now. And here's a super simple example of the kind of thing I might be interested in, recommend books about the horror genre, for example. Okay, so if I do this, there we go. You can see that the result being returned here is JSON, and it's returning the top 5 results here. And as part of this output, we are actually getting the result of the dot product operation as well here. Okay, so I think I'm trying to do this. It's not, no, it doesn't like it. Sorry about that. I thought my magnifier might be able to work, but it's treating the entire text as one block rather than letting me focus on specific area of text. So there we have the details of the book. We have a title. We have some areas in terms of the subjects, you know, whether it's fiction, horror, general, and so on. What is the format? You know, is it audio, hardcover, softcover, so on? And the result of the dot operation, again, I'll try and highlight this with my arrow here. Here we are. Okay, so these values, it's printing the highest value at the top, and then here we're getting the results of 5, you know, the top 5 best answers for this. Okay, so there you can see there's a substantial chunk of text for that one in terms of its description and so on. Okay, so that's one way that we can deal with the JSON. At this point in time, probably what you'd want to do is to take this output then and build some kind of nice visual front end to this. You could do it through this notebook environment, I guess, or, you know, perhaps some other tooling. If you were using something like the mean stack, for example, you have some familiarity with other GUI tools. I just spent a little bit of time last night using a little bit of Streamlit. Okay, so again, Matt, please keep me straight. So I may be showing something that doesn't appear, but there we go. If I run this, okay, so not much to it, as you can see. So literally, there's just a simple box to enter the text on the left-hand side here. You can see, and if your eyes are kind of sharp, you'll see that this is the actual text entry box. And then on the right-hand side would be the actual recommendations. Okay, so let's try something. And sometimes you see kind of interesting results. So let's try something. Horror, I could write the complete sentence here. Yeah, please recommend to me books about science fiction and horror. All right, if I can spell, there we go. Let me just get that. Science fiction. Yeah, I think that's better. Let me just take a look at that. All right, there we go. There we go. Just hit that. Okay, and there we are. It comes back with the top 5 results. So it's essentially, this is the equivalent of what we saw in the notebook just a moment ago, but it's just formatting it in a slightly nicer way. So I'm getting the title, the description, the first 200 characters of the description, right? Otherwise it just fills up the page, as well as the price on the right-hand side. And so let's have a look. I can see there is a reference here to Frankenstein, okay? Dead City here, Paladin Prophecy Alliance, Ceremony of the Innocent, okay? So this looks like it's a reasonably good result there. Sometimes when typing this in, for example, if I would say books about cars and buses, if I do that, this occasionally you'll see, and I think in this particular case, I don't see it, but let me just try books about cars. I think there was something I noticed specifically a little bit earlier. There we are. And in this case, let's have a look. Now, again, I don't see it. I should have kept that particular query. But the interesting thing is that none of the books had any reference to cars, but there were some references to transportation. So you can see that there is a bit of fine-tuning that still needs to be done here. But overall, it does a pretty good job. So here, at least with this particular set of books that are input, which is a fairly small data set, much smaller than perhaps you would have, you can choose to create the embeddings for all of them. You know, depends how large your database is, or you might be quite selective. Simply because if you think about it, let's say there is 100 products that are very popular, or lines in your business that you really want to sell, and you might want to focus people's attention just on those. So you could create the embeddings for those. So when people search, they are presented with those as the sort of top answers first before anything else. which may be based on other things like what the customer has purchased in the past, for example. So again, very simple kind of interface, but a slightly nicer way to see the output and kind of control what it is that we are visualizing rather than the JSON itself. Great. So let's go back to our slide deck and let's take a look here. Okay, so just a quick reminder again for the draw here. AirPods Pro, okay, so bit.ly/fast-AI-JSON-raffle, or you could scan that QR code there. And just to summarize then what I think were the sort of key things that we tried to cover today, and hopefully that has been useful for you. So utilize both vector and JSON capabilities in the same engine. So you saw that Kai can handle, SingleStore can handle JSON anyway. But with Kai, it gives you a much more compatibility with one of the leading NoSQL database engines on the market, the ability to work with JSON data, create the vectors, as you saw that we did. And my colleague, Jason Thorsness, did this previously as well in his webinar. All in the same engine. We can use this to power Gen AI applications. The performance that we've seen versus MongoDB for analytics, 100 to 1,000 times faster. We talked about the variety of different benchmarks in the previous webinar that I did with Vijay. Without any query changes or data transformations. So this, there is a list of fully supported functions. There are obviously a few things that are still not quite there yet, but we have customers using this and evaluating this already. I'd recommend that you do so as well. The CDC, awesome tool, great way to, again, augment MongoDB. So use it for the transactional aspects of your application or your environment, if that's what you wish for, simply because you've invested a lot of time, effort, and money in that technology. You don't have to give it up. But using this, we can replicate the data across to a SingleStore very easily, and then be able to run analytics and other capabilities. And remember, this pipeline is running. So this is something that you don't have to worry about. As new data arrives on one end, it gets propagated across to SingleStore. And this technology, SingleStore Kai, no separate costs or license fees, available today on quite a large number of AWS regions. Azure coming very soon. And with that, I think, Matt, you would wish me to just mention this again. So, yeah, and that's, there we see two of my colleagues there. So my boss, Maduka, probably shouldn't be pointing an arrow at him, but, and my colleague will be doing this. I'll probably get told off. So,
awesome.
Well,
let's start the Q&A. Unless there's anything else you wanted to cover, we've got some questions in the chat.
No, I'm good, Matt. And if with your permission, I can just let's have a look. Try and exit from here, and there we go. Yes.
Sounds. While you're closing down your screen here, I will pose the first question to Eric, who I believe has joined us. At the beginning of the webinar, we got a couple questions about graph data. Eric, do you mind chiming in and talking about support for graph data?
Sure. So in SingleStore, you can store graph data and table structures, to store your relationships just as rows in a table. And we have something called recursive common table expressions, or recursive CTEs, that lets you, in a single SQL query, traverse a graph or tree structure.
Awesome, good stuff. I will give this one to you, Akmal. There's multiple here kind of related from Anthony. In this example, does the Python code for the book embedding run in real time on new records that are coming through the CDC, or is this running on a given schedule?
That's a great question. I was hoping someone would actually ask that, so thank you very much. So with this particular scenario, no. there is no schedule for this to run. But that's not to say that you couldn't introduce one. And actually, Arnaud is here because he's working on some stuff where we can do kind of serverless stuff as well. So literally, as you are loading the data in, you could create the embeddings as part of that process as well. That could be something that, you know, some customers may require. I did the embeddings kind of offline, if you like. So the CDC is simply replicating the data across. It's not doing much more than that. And it's the embeddings, it's also rather selective in the sense that it's not generating them for all of them. It's that scenario that I mentioned that maybe you want to focus people's attention on a small subset of the overall data. Let's say we've got 10 million or 100 million books in our bookstore. Let's say we are the biggest bookseller in the world. We may not necessarily want to create embeddings for every single book, but we might want to do so for a sort of smaller number. So in this scenario, it is not run on a schedule, but we could configure it to do so. And that's one possibility. And again, Arnaud maybe has some thoughts on this, and Eric too, they could chime in with how we might be able to do triggers and things like that, for example.
Yeah, for our cloud offering, you know, when you had a question as well related to how you executing the code in the database, whatever is in notebook, if it's SQL, it will be executed in, you know, like in the database, but the notebook is hosted in a compute that's isolated for security purpose. Our, you know, like our goal is to make that notebook schedule. Like you can schedule a notebook, you can trigger, you can run a notebook. So essentially, if you have SQL and Python, you know, you will be able to schedule that job. So if you have a library using sentence transformer, you will be able to schedule it, you know, every hour, every minute. We will also have the same container to do real-time pipeline transfer. So essentially, as your data comes in, you can create embeddings in real time. Like we'll have both use case. So notebook is just a starting point, but it's a starting point to get ETL and ML flows into SingleStore as well. So you have full control of your data within SingleStore.
Awesome. Akmal, I'll give this to you unless you defer it to Arnaud, given the topic, but it's from Pablo. It's in this type of integration with MongoDB, SingleStore inherits fault tolerance mechanisms embedded in Mongo environment, or does SingleStore provide an extra layer of protection against concurrency or eventual consistency?
Okay, I'll just say a couple of words. I think Eric and Arnaud are probably better qualified to answer this than myself. So here we're just dealing with the data. Okay, the pipeline is essentially just dealing with the database and the collections, and whatever the JSON format is, that's what's coming across. The fault tolerance in terms of the pipeline, well, the thing is, like I said, you could stop it. And in the meantime, data might accumulate on the Mongo side. You could resume your pipeline because I think it interrogates the oplog on the Mongo side in terms of picking up the changes. So that's one aspect of it. But beyond that, SingleStore has fault-tolerant capabilities as well, disaster recovery, all of these kind of things. So that's fine. But again, as I said, I'll defer to Arnaud and Eric because I think they're better qualified to answer that question.
Yeah, regarding fault tolerance in SingleStore, we have built-in high availability, including multi-availability zone redundancy. And also we do support database transactions, or known as ACID transactions. So the transactions are atomic, all or nothing, and then we have concurrency control. So that's all built in.
All right, good stuff. This question was also from Pablo. If I'm currently serializing data using Avro in MongoDB and I want to maintain the same data model in SingleStore, would it be better to continue serialization in MongoDB and then transfer the data to SingleStore? Or should I eliminate MongoDB and use a service, maybe Kafka, to directly ingest data into SingleStore?
That question is it's hard to answer that question without knowing more, but you could do either if you like. If you have like MongoDB application software already written and you want to be able to use those same queries against the same schema structure with MongoDB commands, then you can replicate stuff from Mongo into SingleStore. If you are open to switching your application to point directly to SingleStore, you certainly could load data directly to SingleStore in Avro format. You can use structured and JSON fields, and you could use SQL access through whatever API you prefer, like the could be the Python API that Akmal demonstrated. So you have your choices.
And I think one point I'd emphasize there as well, Matt, for Pablo's benefit, is that notice that, okay, apart from the SQL, which I showed in terms of setting up the pipeline, in the notebooks themselves, there was not a single SQL command, which some people may be very happy about, but it does give you a lot of flexibility. And in case anyone is wondering, does this link capability and the ability to run this CDC not come from the Python side? Indeed, it does. Okay, and if you're interested, contact us and we'll show you how to enable it. Okay.
Good stuff. Akmal, I'll give you this next one. Does this call OpenAI every time there's a new query or not?
It will call OpenAI every time my question changes in terms of the recommendation I'm looking for. So remember, the embeddings for what's stored for the books themselves is a one-time operation. That's I just pay a small amount for that. And by the way, when I check on the OpenAI website in terms of usage, it's like a few cents, all right, even less than that. Right? Their prices have come down enormously since the beginning of the year. And so the particular model that I'm using, I mean, it charges such a small amount for the number of tokens. So even for this example, I'm literally, I mean, I wouldn't say it's free, but near enough. Okay, I mean, it's close to that. But yes, I pay for the privilege in terms of the question that I ask each time, for example, for a different recommendation, or I ask my system for, you saw me typing in books about cars and buses, for example, or I might be asking about horror books or science fiction or something like that, for example, in terms of recommendations. My English sentence gets sent to OpenAI, embeddings are created from that, and that is part of the operation as far as the dot product is concerned. So yes, that happens every time, but for the books themselves, I mean, it was a one-time operation that I did, and they are stored in SingleStore.
Awesome. Akmal, we might have time for one or two more before we announce the AirPods winner and wrap up.
Yep.
But Akmal, is there a way to call the embeddings only when the book data is not already in SingleStoreDB? Same is applicable when loading data for the first time on scheduler basis, etc.
Oh, good question. Offhand, I can't give an answer to that. It's something I need to think about. I know, Eric, any thoughts on that one? But
well, I mean, it says, is there a way to call embeddings only when the book's data is not already in SingleStoreDB? I don't know, you have control over when you call OpenAI. You got application software, then you've got new pieces of text that you might want an embedding for. You can call OpenAI to get the embedding for a new piece of text whenever it suits your application. Like you could call it before you load the data, or you could load the data and then asynchronously like go get the embedding and then update the record that you inserted at a later time. It's really up to you as an app developer, I think.
Yeah. Okay. So I understand the question now. Yeah. Sorry, I was a little bit confused. Yeah, there's a lot of flexibility there. So I think with the example that I showed, it doesn't create embeddings for absolutely everything. I mean, it does it for a subset. And even there, for example, if you're getting new stuff coming from the Mongo side, obviously that's new data that's arriving, which is going to increase the size of the books table on the SingleStore side. And so it's really, either set up some logic to check how the collection has grown, maybe identify things that you want to create new embeddings for rather than doing it for absolutely everything, or, just set up some kind of trigger mechanism, as Anna was suggesting, that you could do that to run on a regular basis to check to see, is there new stuff? We would like to create an embedding for this because it's new and hasn't been previously processed. You can do it that way. I think there's a variety of different ways to handle it.
And Akmal, yeah, like I will say for Squirrel, when we ingest new documents for Squirrel in our database, we don't need DVs to be updated real time.
Yeah.
We can have like 1 minute, 10 minutes. However, when someone asks a question and we want to do an embeddings to do semantic search, then it's real time. It really depends on the use case you have. Your like long-term memory, I don't think you need exactly at the second. And there are efficiencies to do that in batches than doing that real time, So.
Good stuff. Let's wrap up. We're over time here and announce the winner. Reminder, come join us next week for ChatGPT for product-led growth. Talk to your Salesforce or segment data. I have put the bit.ly link to register for that in the chat. And then the announcement you've been waiting for. Today's AirPods winner goes to Pablo Lopez, who is an engineering specialist at RMXC. Congrats and thanks for joining. If that's not you, don't give up. We're going to announce one more AirPods winner by the end of the day for anyone who has tried out Akmal's GitHub demo. So I put that in the chat. Feel free to check your email also in the next hour or so. Try it out, have fun with it, and get one more chance to win those AirPods. Thanks so much to Akmal for an awesome presentation today. Thank you to Arnaud and Eric as well for joining the webinar support team. And thank you to our audience for joining us. Have a great rest of your day. Bye, everyone.